Today's lesson will be on Chapter 6, Section 6, Systems of Linear Inequalities. In the textbook, we are on page 400. As a little inequalities review, we've been covering these for the past couple days in class. These are the less than and greater than symbols. Less than is on the left-hand side, and our greater than symbol is on our right-hand side. When we graph these inequalities on a coordinate plane, they are going to result in a dotted line. And over here we have less than or equal to and greater than or equal to. Less than or equal to is on the left-hand side, and greater than or equal to is on the right-hand side. And when we graph these on the coordinate plane, we are going to have a solid line because of that equal to sign underneath the inequality symbol. That little line right there automatically means we're going to have a solid line. So we see that line underneath, solid line. No line underneath, we're going to have a dotted line. And when we graph the inequalities, we must shade. In order to do so, we're going to test a point not on the line. I test 0, 0 because most of the time that's not going to be a point on the line. And if it's true, we're going to shade towards the 0. And if it's false, we're going to shade away. We're going to go over that in a couple of examples. So we're going to graph the following. Y is less than 5x minus 5. So the first thing we need to know is what our y-intercept is. And our y-intercept is negative 5. That's always going to be the number plus or minus. It's going to be after that slope. And our slope is 5. Because our slope is a whole number, it's always rise over run. So our rise is going to be 5 and our run is going to be 1. So that means we're going to be going up 5 and to the right 1. And because it's a less than sign, we're going to have a dotted line. So over here is our graph. Our first thing that we're going to do, remember this is our y-axis going up and down. Our vertically is our y's, and horizontally over here, this is our x-axis. So first things first, we got to plot our y-intercept. So at negative 5, we're going to put a dot. And then our slope tells us to go up 5 and over 1. We're going to put another dot here. And we're going to continue on. Instead of doing like a short 1 or 2 dots on the graph, we're going to make a couple more. Up 5 over 1, up 5 over 1, and then because I also want to extend the line going down this way, I kind of can't go down 5 into the right one because then it will put the dot over here, and that doesn't make sense because then our line would kind of not be straight. It'd kind of be like a little curve looking. So we're going to go down 5, and now instead of going to the right one, we're going to go to the left one. And because we said it was a dotted line, we're going to make our dotted line. We're going to connect all these dots. And then because we have this less than sign, because it's an linear inequality, we have to test. So we have to see which way we're going to shade. And to test that, we're going to test 0, 0. Because we're going to do that because 0, 0 is over here. That's the origin of our graph. Our line is not passing through the origin, so it's easy to test 0, 0. Remember, this 0 is your x value, and this 0 is your y value. So wherever you see an x, we're going to plug in 0. And wherever you see a y, we're also going to plug in 0. So we're left with 0 is less than 5 times 0 minus 5. And once again, when we plug in, we're not replacing this entire thing with 0. It's 5 times x, so we're left with 5 times 0. We go ahead and simplify this. So we're left with 0 is less than negative 5. 5 times 0, we get 0. And what's important over here is because since it's a minus 5, we got to carry this minus sign down because that means that 5 is negative. If it was a plus 5, you wouldn't necessarily need to carry down that plus sign because we automatically assume any number without a sign in front of it is positive. So we're left with 0 is less than 5. Is 0 less than 5? No, 0 is not less than 5. It's false. So that means we're going to shade away from 0. We're not going to go this way because that would have had to have meant that 0 is bigger than negative 5. 0 is not bigger than negative 5. So we're going to shade away. We go ahead and we shade away from 0. And that's the solution to this problem over here. Y is less than 5x minus 5. Now we're going to review y equals lines. We're going to graph the following. Y is greater than or equal to 3. So we pull up our little graph over here. Once again, going up and down vertically is our y-axis, and horizontally over here is our x-axis. So at our on our y-axis, we're going to plot a dot at 3. And then it's a solid line because it's greater than or equal to. We got that little line underneath right there. Means we have a solid line. We go ahead and we draw in our solid line, but we're not done just yet because it's y is greater than or equal to 3. So we have to shade because it's a linear inequality. And which way do we shade? We're going to test 0 because this line does not fall on 0. We can definitely go ahead and use 0 to determine which way we're going to shade. So wherever there's a y, we're going to replace it with our 0. So we get 0 is greater than or equal to 3. 0 is not greater than or equal to 3. It's false, so we're going to shade away from 0. And that's how we shade away from 0. We shade going up to the top because any number up here is greater than or equal to our positive 3. Any number below here is essentially less than or equal to negative 3. And our problem is telling us it's y is greater than or equal to negative 3. So that's why we're shading above. Now we're going to review x equals lines. We're going to graph the following. X is greater than negative 2. Once again, here's our graph. This going up and down vertically is our y-axis. Horizontally, left and right, this is our x-axis. And we have x is greater than negative 2. So we're going to go and find out where on our x-axis where negative 2 falls. And it falls right over here. So at negative 2, we're going to put a dot. And is this going to be a solid or a dotted line? Because it's strictly greater than, solid or dotted. Because it's just greater than, we're going to have a dotted line. So I'm going to go ahead and then draw in that dotted line. And next, we got to see which direction we got to shade. Why do we have to shade? Because we have a linear inequality, because we have x is greater than negative 2. And how do we know which direction to shade? We're going to test 0. So we have x is greater than negative 2. And then for x, we're going to put a 0. So we have 0 is greater than negative 2. Is 0 greater than negative 2? Yes, it is. It's true. So now we're going to shade towards 0. Any number to the right, any number over here, any number towards 0 is greater than negative 2. So we could go ahead and shade in here. Like we did in the example, 0 is bigger than negative 2. So that's why we're going to shade. If for some reason I decided to pick 3 as our point and I filled in 3 for x, 3 is greater than negative 2. So that's why this one is shaded towards 0. Any number to the right of negative 2 is true. And now we're going to go ahead and graph systems of linear inequalities. What that means is we'll be graphing 2 equations on a single graph. So basically you're going to have to plot 2 lines on one graph. So over here I'm going to give you what is the graph of the following system. We have y is less than 2x minus 3 and 2x plus y is greater than 2. What's a little funky about this line down here is it's not strictly y equals. This top line, we have y is less than 2x minus 3. We're okay with that. It's a y equals line. Down here, we have 2x plus y is greater than 2. Our y is not isolated. It's not all alone. So we got to go ahead and rearrange this equation. So we have to rearrange 2x plus y is greater than 2. And how do we go about that? Well, we want y equals by, or y by itself. So we got to move this 2x from over here to over here. And the only way to do that is to subtract 2x from both sides. When we go ahead and subtract 2x from both sides, we're left with y is greater than negative 2x plus 2. So now I took those two lines, or those two equations that we had from this slide over here, and I just rewrote them at the top. What we got to do for these two is we got to identify the slopes and the y-intercepts for both of these lines. So if we're working with the line on the left-hand side, our y-intercept is negative 3. And their slope is 2. Because it's a whole number, our slope is rise over run, so we have 2 over 1. Any slope that's a whole number is always over 1. So we're going to go up 2 in this line and always to the right 1. And in this line over here on the right-hand side, we're going to identify our slope and our y-intercept. And in this case, our y-intercept is positive 2 because we have a plus 2. And our slope is negative 2 because it's a whole number. It's rise over run. And our slope is negative here. We can't drop off that negative sign. So our slope is telling us to go down 2 and to the right 1. So now we pull up our graph and we graph each of these lines separately. We're going to work with this line first over here. So our y-intercept is negative 3. So at negative 3, we're going to put our dot. And then our slope tells us it's 2 over 1. So we're going to count up 2 over 1, up 2 over 1. And then, because I wanted to kind of extend this line a little further, I wanted to go this way. Well, I couldn't go up, or I couldn't go down 2 into the right one. Instead, I went down 2 into the left one. And then what type of line are we going to have? Are we going to have solid or dotted? We're going to have a dotted line because it's strictly just less than. So now I'm going to go ahead and fill in my dotted line. And it's okay, I extended it across the whole graph. That's not a problem. It's a little better because you see how we have two equations. We're sort of looking for where these two equations are going to meet. We're going to go over that in a second. So now we have to graph our second line on this same graph. We're not making two separate graphs. We're putting them on the same exact graph. So your first thing, we're going to plot our y-intercept, which is positive 2. And then our slope tells us to go down 2 and to the right 1. Down 2 and to the right 1. And then once again, kind of want the line to go a little bit more this way. So now I'm going to go up 2 into the left 1. And now the same thing next. We have to figure out solid or dotted line. And it's going to be a dotted line because this is strictly just greater than. So I'm going to go ahead and draw in my dotted line. Now we got that. So now we have this line over here, which corresponds to this equation. And then we have this line going this way, which corresponds to this equation. What we got to do next is we got to shade each of these lines in separately. So to do this first line, notice both of these, none of these lines pass through the origin, none of these pass through 0, 0. So for this first line over here, I'm going to test the point 0, 0. As a reminder, this is x and this is y. So wherever there's an x, I'm going to plug in 0, and wherever there's a y, I'm going to plug in 0. So if I go back to this original equation and I plug in 0 is less than 2 times 0 minus 3. We go ahead and we solve it. 0 is less than 2 times 0 gives us 0 minus 3. And we're left with 0 is less than negative 3. Is 0 less than negative 3? No, 0 is greater than negative 3. So because this line is false, we're going to shade away from 0. So we're going to go ahead and shade in. So for this particular line right here, I'm going to shade away from 0, so I'm shading down this way. Now we got to repeat the process for this line over here. So we're going to do the same thing. We're going to test 0, 0. As a reminder, this is x and this is y. So we're going to fill in wherever there's an x, we're going to plug in 0, and wherever there's a y, we're going to plug in 0. So we're left with 0 is greater than negative 2 times 0 plus 2. And we go ahead and simplify. 0 is greater than negative 2 times 0 gives us 0 plus 2. 0 is greater than 2. Is 0 bigger than 2? No, 0 is not bigger than 2, so it's false. So we're going to shade away. As a reminder, we're shading this line right here, so we're going to shade away. We're going to shade over here. Now, what gets a little tricky with these graphs is, do we notice how one graph we're shading going this way, and then the other graph we're shading going that way? We're looking for where the shading overlaps on these two graphs, and it's overlapping right in here. And where it overlaps is essentially where our solutions for these two graphs, where our solutions for that system of graphs lies. So now what I'm going to go ahead and do is I'm going to kind of shade it in a little darker. So this black shaded region is now, it represents, the black area represents the solution. So this is where our answers lie. We can, if we wanted to on our papers, we could go ahead and erase this blue section and this red section. It's completely up to you. But on a quiz or a test, what you guys would have to do is you would just have to shade this area in a little darker. So this one would be the most bold section because that's where our entire answer selection would be. And some daily reminders. Your homework will be posted in PLUS portals. You must show all work. Your name should be at the top of the page. When you complete your assignment, you should email me your completed homework prior to the start of our scheduled class time. If you do not email me prior to the class, or if you email me sometime during class or after class, your homework will be late. If you just decide not to do it or I don't receive it, you don't send it to me, you'll get an incomplete. Your details regarding the quarterly assessment will be emailed to you guys later on today. And there will be a quiz on graphing linear inequalities on Thursday, March 19th. If you guys have any questions about this lesson, if you have any questions in general, please feel free to email me and I will get back to you guys as soon as possible.